In this video, we'll look at Maxim's new Himalaya family of step-down or buck DC-DC converters and look at why you should consider this new generation of DC-to-DC converters for your next design. Traditional non-synchronous converters use an external diode to rectify and conduct the output inductor current during their off time. This technique is simple to design. However, the external diode dissipates heat due to its forward voltage drop. A synchronous converter, on the other hand, replaces that external rectification diode with a power MOSFET integrated into the converter. The MOSFET's low resistance makes for a relatively small voltage drop, and a smaller voltage drop means lower power loss and cooler operation, which means more efficient operation. This permits a higher switching frequency and makes for a smaller solution footprint. Thanks to new advances in the integration process, the MOSFET and other components are now part of the DC-to-DC converter itself, so the total converter solution is simpler. They allow you to pack more into a smaller enclosure and can lower your total system cost. Let's compare a Maxim synchronous converter to a non-synchronous design. At 24 volts input, 3.3 volts output, and 2 amps output current, the Maxim solution is running at 87.3% efficiency and has an IC temperature of 42 degrees C. The non-synchronous alternative has an efficiency down at 65.7% and has an IC temperature of 81 degrees C. Over 20 percentage points less efficient and 39 degrees C hotter. Heat also affects your system's reliability. Every 10 degrees C rise in temperature cuts the life of your circuit in half. So naturally, a 39-degree difference means its life expectancy is just over 1/16 that of the cooler solution. Maxim synchronous DC-DC converter products allow you to select from 3 modes of operation. If your design involves light loads, then you will appreciate the flexibility that these 3 modes offer. For medium to heavy loads, the efficiency of all 3 modes is the same. For light loads, PWM, pulse width modulation, offers fastest load transient response because it allows the output conductor current to go negative for light load conditions. However, PWM mode is not as efficient as the 2 other modes. DCM, discontinuous conduction mode, emulates the traditional non-synchronous converter. The inductor current doesn't go negative. For light loads, DCM is more efficient than PWM, but not as efficient as the 3rd mode, PFM. PFM, pulse frequency modulation, prevents negative inductor current, skips pulses, and turns off internal circuitry to save power during light load conditions. This mode offers the best light load efficiency if your application can tolerate a bit higher output voltage ripple. Here is an efficiency comparison between non-synchronous DC-DC converters and Maxim's synchronous solution in each of the 3 modes. Now let's switch gears and discuss how Maxim's Himalaya DC-DC converters can save on the cost of the output inductor. Maxim has optimized the MAX17503 Evaluation Kit for highest efficiency, but perhaps you want to use an output inductor which is different and lower cost. When you replace the output inductor from the Evaluation Kit with an inductor which is half the price and has over 3 times the DC resistance, the converter efficiency drops less than 1 percentage point to 86.4%. Evaluation kits for Maxim's Himalaya family of synchronous DC-to-DC converters are available now. We think you'll agree. They're the coolest power product you've seen in quite a while. Order yours today.